Hi, it's Harry here. So this is part 3 of my video about how to use Shiny app to create AE tables. So in the part 2, we discussed some Shiny app which asks the user to put the values of the treatment variable in a CSV file. The Shiny app reads the CSV file, gets the information about the treatment, and creates the AE tables accordingly. But there is a limitation in that app. That Shiny app assumes that there are only 2 treatment groups. So in some studies, there may be 3 treatment groups or 4 treatment groups. So really, we want to make some improvement on the Shiny app. We want to design the app so that it can read the CSV file, count the number of treatment groups, and create the tables accordingly. So let's see how we can do that. Before we look at the app, let's look at the data sets. So there is a small R program in the screen. It's using the Haven package to read the sets data set. So let's run this R program. Okay, so in the ADSL, the first column is the treatment. So you can see it has a value active treatment A, active treatment B, and placebo. And you have the U subject ID here, you have the safety flag. If we look at the ADAE, the first column is U subject ID, then the next 3 columns are the AE terms, the preferred term, the system organ class, and the high level term. Then you have the treatment emergent flag, safety flag. The last column is for the treatment. It has the values active treatment A, active treatment B, and placebo. Okay, so let's go back to the app. This app is gonna read some CSV file. So let's look at the CSV file first. Okay, this is the CSV file. So open with text edit. Okay, so you can see in this CSV file, there are 3 rows and 2 columns. The first column are just the numbers 1, 2, 3. The second column is for the values of the treatment variable. So notice that the order of the treatment groups are very important. If you want to display placebo as the first treatment column in the AE table, then you will need to put this placebo in the first row of this CSV file. Okay, now let's see. We want to. So how does this Shiny app create the AE table? So let's run this app. Okay, first we want to input the CSV file. Okay, now upload ADSL. Next tab is upload ADAE. Okay, we click on one level. So you can see we have this AE table for preferred term. It has 4 columns. You get the 3 treatment columns and also the total column. If we click on the 2 levels, so this is for the system organ class and the preferred term. The system organ class is in light gray. You have the 3 treatment columns and the total column. And if we click on 3 levels, okay, so you have 3 treatment columns and the total column. You have system organ class, high level term, and the preferred term. The system organ class is in dark gray, the high level term is in light gray. So it looks good. So how does the app work? This app is heavily dependent on some R function. So let's look at that function first. Okay, so here's the function eval parse text paste 0. So when do we need to use this function? This is when we we are running some loop, and there is an index number in the command. This eval parse text equal to paste 0 can replace the index number by some number and correctly evaluate the command. Okay, so let's look at the R program. Okay, at the beginning of our program, we load these R packages. We need the Haven package for reading CSS data. We need the Shiny and the Shiny themes for the app. We need the tidyverse package because we're gonna use some functions from that package, and we need the GT package. That's for creating the table. We put the date information in this variable, the date. Okay, in the UI part, excuse me, in the UI part, we created those tabs. So here we're using tab panel. We create the input CSV file tab, and here we have upload ADSL tab. We have upload ADAE tab. We have the 1 level, 2 levels, 3 levels tab. Okay, so let's look at the server part of this R program. We have a return table 1, that's for the AE table with preferred term. The return table 2 is for the 2-level AE table. The return table 3 is for the 3-level AE table. So they are very similar. We will only look at this return table 1 in some detail. Okay, so we start here with reactive programming. First we use a read sets function to read ADSL and ADAE, and then we use this read CSV function here to read the CSV file. We'll put the information in raw data. What we do next is we create a data frame called a VR. This dim raw data bracket 1. So this is the number of rows in the raw data. So if you have 3 treatment groups, this number is going to be 3, and the VR is going to be a data frame with 1 row and 3 columns. And next we're going to do this loop. Here we are using this paste function. So we use this condition. The first column of raw data is equal to I to get a subset of raw data, and we put the information from the second column, that's the value of the treatment variable, into this VR1I. And then in this line we are using the filter function to get a subset of ADSL. The condition we use is TRT01P is equal to VR1I, and the safety flag has to be Y. Okay, in this row we are creating a variable called GRP in the ADSL I, and we give it the value GRP I. What we're doing next is quite similar, but we're doing it for the ADAE. We're using this filter condition to get a subset of ADAE, and we are creating this GRP variable. So here you can see every step we need to use this eval parse text paste 0 function, because in the commands we need this index number I, and this eval parse text paste 0 function helps us to correctly evaluate the command. Okay, here we use do.call to combine those subsets we created for ADSL and ADAE. So what we're doing here, this ADSL tot2, so we're creating this for the total column. We need a variable called num. This num is the number of rows in the raw data plus 1. So if you have 3 treatment groups, this num is going to be 4. And then we create this variable GRP for the ADSL underscore tot2 and assign the value to it. The value is GRP num. Okay, then we do the same thing for the AE underscore tot2. That's for the total column. And then we just use this rbind function to concatenate ADSL tot and ADSL tot2, concatenate ADAE tot and ADE tot2. Okay. Next, we use this table function to calculate the number of patients in each treatment group. This is going to be used in the column header. After this, we use the summarize function. In the summarize function, we use a group by GRP. So here we are calculating the number of patients with at least one TEAE in each treatment group. And then we are using the summarize function, but with group by GRP and the preferred term. So here we are calculating the number of patients in each treatment group and for each preferred term. Okay, here we are using the spread function to do transpose. Oh. Okay, right here. We are using the spread function to do transpose because we want to have the treatment as columns. We use the C function to keep certain variables. Notice here that because we don't know the number for treatment groups, we are using this unique function to get the treatment group from the ADAE all. Okay, here we are using the rbind function to concatenate the AE and A3. In this step, we have to use this eval parse text paste 0 again, because we want to use this order function to sort the data by descending order in the total column. So this variable num identifies the total column. Okay, here we are doing some loop again. What we are doing here is we calculate the percentage. So here we divide the count by big N, we get a percentage. We use the format function to keep the 1 decimal. We use the paste function to combine the count and the percentage. We use the if-else function to handle the scenario where the count is missing. We assign 0 to it. Okay, so again, you can see in every step here we have to use this eval parse text paste 0 function in order to replace this index j by the appropriate value. Okay, and here we are using select function to keep only certain columns. We keep the term, this is for preferred term, and we keep all the variables that ends with underscore C, so that's for all the treatment columns, including the total column. After this, we are ready to use the GT to do the reporting. We have tab header, we have source node, we have cause label. So notice here we are only assigning label to the preferred term because the labels for the treatment columns have to be handled separately, which is right here. So we are using a loop here to assign label to the treatment columns, and the label is here, the VR1S. That's the value of the treatment variable, and also we have this big NS, so that's the number of patients in that treatment group. And again, we have to use this eval parse text paste 0 function and to handle the label of the total column, because we need to use big N num. This num is for the total column. Okay, now we are ready to use the render GT function to create the table. So after reviewing this program, you can see that this whole program is heavily using this eval parse text paste 0 function. So there may be another more elegant way to do this, but at this time, this is the method I can think of to handle this app. Okay, so I hope you find this information very helpful. I'm going to put the data sets and the R programs in my GitHub account, and I will leave a link in the description of this video. And if you like the video, give it a thumbs up and consider subscribing. Thank you.